In this video, we're proving trigonometric identities. This may be an identity, and we would like to prove that it is an identity. Whenever you are proving an identity, you work on one side or on the other, but you don't work across. For example, it's not okay to just divide both sides by the sine of x here. We can't treat it like it's an ordinary equation. We can work on the left-hand side, we can work on the right-hand side, we can try to show that the left-hand side is the same as the right-hand side. But we can't add things to both sides or subtract things from both sides as if we had an equation. I'm going to work on the left-hand side because it seems that it's more complicated, and it's a good idea whenever possible to get rid of these parentheses. To get rid of the parentheses, I'll just distribute this sine of x. So the sine of x times the cosecant of x, that becomes sine of x times the cosecant of x, minus the sine of x times the sine of x. This one becomes sine squared x. We're just working on the left-hand side. Now, it's also a good idea to change things back into the sine and cosine that is making them up. Now, cosecant of x is the same thing as 1 over the sine of x. So here we have the sine of x times the cosecant of x is the same thing as 1 over the sine of x, and this is minus sine squared x. The sine of x times 1 over the sine of x, these sines of x cancel out, and we end up with 1 minus sine squared x. And when you see a pattern like this, something should stand out to you. You should say, I have seen something like this before. Over here on the side, I'm going to remind you that 1 minus sine squared x, one way we can get that is by remembering this very useful identity, cosine squared x plus sine squared x is equal to 1. And if we solve this for the cosine squared x by subtracting sine squared x from both sides, we get cosine squared x is equal to 1 minus sine squared x. So there is this 1 minus sine squared x. Over here we have a 1 minus sine squared x. Trigonometry is one big exercise in substitution. So if 1 minus sine squared x is equal to the cosine squared x, then we can just replace it. We can substitute. And so 1 minus sine squared x is the same thing as cosine squared x. And that is exactly what we were hoping to show that the left-hand side was the same as. So now we have that the cosine squared x is equal to the cosine squared x. And there we have proven it.